Good morning. So I have to start out with a confession. My background is not stormwater, it's ecotoxicology, but these two subjects are becoming increasingly linked. So as an ecotoxicologist, I study chemicals in the environment, where they come from, what effect they might have on animals and people, and how to reduce this environmental contamination and its effects. And so that gives me, so stormwater is a major pathway for many of the contaminants that I study in our lakes, streams, and fish. And so this gives me a common goal with many of you here, that I want to understand how we can provide long-term, cost-effective stormwater treatment so that we can reduce these toxic chemicals and other water quality issues in our local water bodies. I need to find my clicker. There we go. All right. And so today I'm presenting the results of one of the RSMP effectiveness studies called Stormwater Retrofits for Treating Highway Runoff. And this was a study that was selected by the Western Washington stormwater permittees as part of the first round of RSMP effectiveness studies. And for this, we wanted to ask the question of, we wanted to evaluate how well a stormwater retrofit improved water quality in a typical urban basin. But to do this, we wanted to look at it from multiple levels. So first, how did the individual BMPs improve the water quality and reduce these chemicals in the stormwater? And then do we see these water quality improvements in the larger stormwater system and then in the receiving water itself? And so we found a great study site in the city of Shoreline at the Echo Lake Drainage Basin. And this basin is 215 acres with both residential and commercial land use, and it has a few major roadways running through it. And so the city of Shoreline completed a retrofit of the stormwater system in the southern half of the basin in 2012, with plans to complete the retrofit in the northern half in 2015. And this included installing many BMPs, but as part of this, there were 6 bioretention planter boxes in the southern half installed along Aurora Avenue North, which is part of Highway 99. And these bioretention planter boxes were designed to provide enhanced treatment, and it uses the 60-40 compost and sand mix. And these are designed so that water comes off the street through 2 small curb cuts into a catch basin system. And as that catch basin system fills up, the water fills into the planter box, and then water starts to filter through the media to a perforated PVC pipe under drain. And then this under drain joins up with the rest of the stormwater system. And it's important to note here that these are planter boxes, and so they're lined with concrete, and so there's not infiltration happening at this site. And for sampling purposes, we can access the treated effluent through clean out or overflow at the downstream end of the planter box. This retrofit also included a number of Filterra that were installed along the major roadways. And the Filterra were designed to provide phosphorus treatment using a proprietary media. And again, water comes in off the street, this time through a large curb cut, into these Filterra. They fill up and water starts to filter through the media to under drain, which again joins the rest of the stormwater system. And these are also lined with concrete, so infiltration is not occurring at this site. And again, for sampling, we can access that treated effluent through clean out in the Filterra. And so for our study, we included 3 bioretention planter boxes and 1 Filterra in the southern half. And we were hoping to include another newer bioretention planter box in the northern half. But the construction for this retrofit was a little delayed, and it didn't quite jive with our sampling schedule. So we only were able to collect 2 samples at this site. And those data will be included in our final report, which will come out in a few months, but I'm not going to talk about it in this presentation. And so from 2015 to 2017, we took samples at the inlet and outlet for 5 to 8 storms for each of these 4 BMPs. And so this site also let us answer those larger questions of how is this affecting, how would the retrofit affect basin-wide water quality? Because samples were collected at the stormwater outfall to Echo Lake before the retrofit was put in. And also we have a long-term monitoring program in Echo Lake as part of King County's Small Lakes Monitoring. And so we were able to look at these sample results from before the retrofit and then pair them with samples collected after the retrofit. And so by leveraging this existing data, we could take a look at this larger effects to the basin. So there are two more things that make this study unique and interesting. So the BMPs have been around for a while. And so a lot of bioretention studies focus on brand new media, but the planter boxes as well as the Filterra had been online for at least 3 years before we started our sampling. And so this gives us great information for the long-term effectiveness of these installations. The second thing is we included some chemicals that are rarely looked at in stormwater treatment studies, namely PAHs and PCBs. So PCBs are a group of contaminants. They're chemicals that were developed in the 30s and were used for a variety of things, including additives to construction materials like paint and caulking. And the US banned them in 1979, but they are so persistent that they are a continuing environmental and human health issue. And we see that there have been several local studies showing that stormwater is a major pathway for PCBs into our water bodies, which means they get into our fish, which means they get into our bodies. And this is a big deal because are known disrupt hormones. So we also look with a group of chemicals that can be produced through combustion of organic material, like our car here, and so they're also associated with stormwater, and several are known carcinogens. And while PAHs and PCBs are not currently included in stormwater retrofits, or excuse me, in stormwater permits, there are many environmental professionals that are looking for ways to reduce these contaminants in our waterways, and so including, or just understanding how well common BMPs are already reducing PAHs and PCBs is really valuable information for our community. So let's get to our study. In February 2015, my field lead, Christopher Barnes, and I went out to the site to take a look. We were starting the planning phase of our study, and it had been raining all week, and so we wanted to see how these BMPs were responding. And at the first planter box, we noticed it was pretty dry. So we went to the catch basins, so this is where the water comes in off the street to get into the planter boxes, and the water level was about 3 inches below where it needed to be to get into the planter box, which is not what we were expecting. So it looked like these hadn't been receiving stormwater for a while. So we got to the street and we see that these small curb cuts were completely blocked with dirt and debris. And so it was cutting off the stormwater from getting into the catch basins completely. So we cleared those out and water was flowing in. So we went around and looked at other planter boxes, and same thing was happening. And so we talked with the city of Shoreline, and they scheduled a maintenance visit for the other planter boxes in the area. But we went back a few weeks later, and there was a little bit of debris that had built up again. Not as much as before, but it was enough to, again, completely cut off the stormwater from getting into the planter boxes. So we decided that for the purposes of this study, we would need to come out about every other week to clear these out and make sure that they were online for our study. The Filterra didn't have this problem because they have much larger curb cuts, so those were completely clear. But when we opened up the lid, we saw that it was flooded, and it didn't seem to be draining. And when we came out a couple weeks later, it still looked like that. So again, we talked to the city of Shoreline, and they had the company come out and replace the media in the Filterra that had been installed. And so they had been already in place for about 3 years. So that was one thing. We were hoping to look at older Filterra media, but it already was needing to be replaced. And so the Filterra results I'm showing are for new Filterra media. So we went back after we were all done with our project plan. We had a big storm hit in December 2015, and we went out and water was flowing. We had kept those curb cuts clear. Hooray, we can start our sampling season. So for each of the following storms that we sampled, we would take samples at the inlet of the planter boxes, as well as the Filterra, and also at the outlet. So this is the treated effluent now, and we're accessing those through the cleanouts that reach the underdrain. It's a similar story at the Filterra, it's just smaller, and I don't have good pictures that you can really see. And then we took these to the lab. We had the King County Environmental Lab do a lot of our analysis, but for PCBs, we had to contract that out to Pacific Rim Laboratories. And so for each sample, they were analyzing contaminants in the influent and the effluent. And our parameter list included total suspended solids, dissolved copper and zinc, total phosphorus, total PAHs, total PCBs, and we also conducted some toxicity tests at one of the planter boxes. We also looked at total nitrogen, dissolved nutrients, total metals, bacteria, petroleum hydrocarbons, and field parameters like dissolved oxygen and conductivity, but those in orange I'm not going to cover in this presentation, but they will be in the final report. So I'm going to walk through our results using the TAPE performance goals because these were designed to satisfy some of those. I want to be clear that this study was not following those TAPE protocols. Notably, the sample size we used here was much lower than what's required in TAPE, but I'm using it as a way to look at how well these might be working compared to the performance goals. So basic treatment. Both the planter boxes and the Filterra were designed to meet basic treatment, and so that's greater than 80% total suspended solids removal on average, or less than 20 milligrams per liter total suspended solids in the effluent, depending on the influent concentrations. And I'm going to use a series of figures to talk about this, showing the average concentration at each site. So we have our 3 bioretention planter boxes and 1 Filterra, and right now I'm showing the average concentrations of total suspended solids in the influent. You can see we started out about 100 milligrams per liter on average coming in, but each of these BMPs significantly reduced total suspended solids in the effluent, and we ended up at an average that was generally less than 20 milligrams per liter. I think my scale moved a little bit. Those are all less than 20 milligrams per liter. We found that the bioretention planter boxes surpassed the performance goals, and many sample pairs showed that there was greater than 90% total suspended solids removal by concentration. And then the Filterra also consistently reduced suspended solids, but the degree to which it reduced it was variable, and so it was unclear if they would really be meeting the performance goals. Then the bioretention planter boxes were designed to provide dissolved metals treatment, and this includes greater than 60% dissolved zinc removal on average. And so, and this is supposed to be for concentrations of zinc between 0.02 and 0.3 milligrams per liter. And so we were below this design range for our influent concentrations, but the planter boxes were still able to successfully reduce the dissolved zinc concentrations and meet this performance goal. The Filterra, unfortunately, increased dissolved zinc on average and did not meet this performance goal. Dissolved metals treatment also includes greater than 30% dissolved copper removal for influent concentrations between 0.005 and 0.2. Sorry. All right. But we were a little closer to this design range, but we were still mostly below. And at the bioretention planter boxes, we saw that influent dissolved copper concentrations were pretty comparable to effluent dissolved copper concentrations, while at the Filterra, dissolved copper generally increased, and we never saw a pair of samples that showed that greater than 30% dissolved copper reduction we're looking for. But the Filterra were not designed for dissolved metals treatment. It's just important to look at as we compare these. They were designed for phosphorus treatment, and this is greater than 50% total phosphorus removal on average. And here, this is for influent concentrations between 0.1 and 0.5 milligrams per liter. So we were within the design range. And the planter boxes significantly increase the total phosphorus. But the Filterra did successfully decrease total phosphorus on average. But again, the degree to which it reduced it was variable, and it wasn't clear that it would meet that 50% removal performance goal. So what about the other chemicals we looked at? We have our PAHs and PCBs. So total PAHs were significantly reduced at each site. The second and third planter boxes, they were virtually eliminated. We had very few detects in the effluent, and we were using pretty low detection limits. The PCBs were also significantly reduced at each site. This was really exciting. We actually had concentrations of PCBs coming out of these that were around what you would find in clean laboratory water. It was really impressive, and this is one of the first, maybe the first study that's looked at PCBs in this way for stormwater treatment with bioretention like this, and so these are pretty exciting results. We have one more batch of PCB samples coming in, so these are preliminary, but they were really consistent. So I want to talk a little bit about how flow changed it at these sites. We didn't measure flow with the flow meters. We didn't have space to fit those in at the site where we were at, but we could visually observe at the planter boxes that flow was substantially reduced. And so I want to talk about how flow reduction relates to pollutant reduction, just to make sure we're all on the same page. So let's do a hypothetical where we have a BMP that is giving us the same volume out as we started with coming in. And let's say we have 6 dissolved copper ions in the influent and 3 dissolved copper ions in the effluent. And so we have a lower concentration of copper coming out, and that's because we have less copper in our water. But let's say that BMP also reduced flow. So now we still have less copper coming out, but we have a higher concentration. We've reduced the flow, which is also great, but this is an important piece to keep in mind if you're just looking at concentration on a loadings basis, so what mass of the contaminant is actually coming out of the BMP might still be reduced if you have a substantial reduction in volume. And so we think this could have been happening at the planter boxes, because what we saw is, and again, there's no infiltration at this site because it's lined with concrete, but we saw that we only could see any effluent coming out through the underdrain during periods of intense rainfall. And so times with lighter rainfall, which is pretty common in Seattle and Shoreline, we actually had no flow coming out at all. And so that means that at those times, there's no contaminants leaving the bioretention in that way. And so that's important to keep in mind with the dissolved copper results, where they were somewhat similar between influent and effluent. If you're looking at it from a mass level, actually the amount of copper leaving, we might have actually still reduced copper at those sites. The Filterra is a little trickier because we couldn't actually see into the underdrain like we could with the planter boxes, and so we couldn't observe the flow to know how much it was reducing. We have a guess that it maybe was reducing flow to a lesser extent than the planter boxes because it's smaller, so there's less media to absorb the water. And also, effluent was flowing at these sites both before and after the effluent had would start and stop pretty quickly in the planter boxes because it really took really intense rain for those to flow at all. And so the other question is, was this water toxic? So we conducted toxicity tests at one of the planter boxes for 4 storms, and we used Daphnia, these water fleas, to do that. And we saw that the influent water was rarely toxic, but when it was, the planter box was able to successfully reduce the contamination. And so that summarizes what we found for the individual BMPs. But what about the basin-wide effects? We looked at the samples that were collected at the stormwater outfall in 2010, 2011, and so that was before the retrofit. And we also collected samples just upstream of the outfall in 2016, and this was after the retrofit had been completed for the whole basin. And what we found is that the water quality at these, between those 2 time periods was actually really similar. And a couple things could be happening here. First, we have limited samples because we were constrained by the number of samples that were collected before. But also this retrofit was done in part to offset some increase in impervious surface that was happening due to a roadway improvements project. And so it could be that with this increased impervious surface, these retrofits prevented a substantial decline in water quality, but with the density that we had of BMPs, we didn't see a major increase or improvement in water quality. And we also looked at the long-term monitoring data, and we are still working those up, and so that information will be included in our final report. But from the information we have right now, it looks like we aren't seeing major improvements in water quality in the lake with the current density of BMPs, so it would require a higher density of BMPs to really get that water quality benefit in the receiving water. But that would be a huge investment, right? So we want to make sure we're getting the most out of that investment. So let's talk about what we learned for operations and maintenance at this site. So the planter boxes, those curb cuts were too small to keep water flowing into them without really regular maintenance of us on our hands and knees cleaning them out. And we did see that there was some increased street sweeping in the second year of sampling, and that decreased the amount of times that we had to, the frequency that we had to do this, but it did not eliminate the problem. And so if biweekly site visits are not a reasonable maintenance schedule for you, you might want to think about designing these with some larger curb cuts like the Filterra. And it's really important that we are finding ways to facilitate flow into these bioretention installations during the design and construction phases of the projects, because we want to utilize the capacity of bioretention, which would maximize the stormwater treatment that we can do and make the most of our investments. But going to the Filterra, they had their own flow issues. This is actually a picture that we took during one of our last sampling events, and the same problem we had at the beginning was happening again, just 2 years after the media had been replaced. And so it seems at this site, the Filterra media needed to be replaced about every 2 to 3 years, which was not what was originally expected. And so this is a good reminder that regular site visits may be necessary to see if your anticipated maintenance schedule is actually appropriate for the site. Because if they're, that might sound daunting, but if they're plugged up, they're not working, and you've spent your money on something that isn't actually treating your stormwater. So just to summarize, because we want this water to get in because they are treating the stormwater pretty well. So at the Filterra, we had excellent removals of PAHs and PCBs. As a toxicologist, that's really exciting. It was also designed for suspended solids and total phosphorus reduction, which it did do. It was just that the degree of reduction was variable. And then it wasn't designed for dissolved zinc or dissolved copper reduction, but if that's a concern at your site, we did see concentrations increase with the Filterra. The planter boxes were designed for the suspended solids reduction and also dissolved zinc, which they did really well. And PAHs and PCBs were also reduced to a huge extent. And we saw that toxicity when present was also reduced. And we also saw huge flow reductions, more than we had anticipated at this site. Dissolved copper, like we discussed, was pretty comparable between in and out. And total phosphorus did increase in concentration at this site. But these installations are 3 to 5 years old. And these are the results that we're seeing with brand new media. So the bioretention work group has been doing a lot of studies on bioretention media. And these are really consistent results. And so that speaks to the longevity of these bioretention planter boxes. And so I'd like to leave you with bioretention can treat your stormwater, but only if the stormwater can get in. Thank you.